Hey, welcome back. So in this video, we're going to have a look at a brand new open source project called SuperDuperDB. Not only has it got the best name ever, SuperDuperDB, I could do this all day, it is actually solving a real problem in the generative AI space. And I think it's going to be an absolute killer application. And that problem is when you're using retrieval augmented generation, and I'll explain what that is in a second, then you have to bring in additional components into your architecture, namely a vector database. And the problem with bringing in a vector database into your architecture, it instantly becomes more complicated and you're going to have duplication. And the problem that SuperDuperDB solves is it means that you can use your existing databases, i.e. MongoDB, Postgres, Sqlite, whatever database you want, to host your vectors without having a separate vector database. And that is killer. In fact, I would say it's super duper. So in this video, I'm going to show you how we can get started with SuperDuperDB. I'm going to show you how it works underneath the hood. And then I think you will get pretty excited about it in the same way as I am. So before we get started with SuperDuperDB, I thought we would just level set on the RAG pattern, or the retrieval augmented generation pattern, just so everybody is on the same page and space. And we can demonstrate that with actually ChatGPT. So if I ask a question such as, who is currently top of the English Premier League, then that is a question that we wouldn't want ChatGPT to be pulling from its own model knowledge base, right? And the reason we wouldn't want that coming from its own model knowledge base is it will only be accurate up to the point of its knowledge cutoff. So what we actually want the large language model to do is to go out to an external source, which is fresh and up to date, and be able to pull back that information and answer the question for us. So in this case, when I ask who's the top of the English Premier League, you'll have seen there it's went off to Bing, it's done a lookup, it's looked at the World Wide Web, it's found out who's top of the English Premier League, and then came back and there you see it came back in a text format as of December the 9th, 2023. So currently now, after its knowledge cutoff date, it's saying Liverpool is currently at the top. And that is what the retrieval augmented generation pattern is really about. It's about understanding the query and then going off to that external source and then pulling back some data, which could be documents, it could be from a database, it could be from a document source, etc. And then taking that, augmenting it with the knowledge from its own knowledge base, and then generating out the new response that answers the query. That is essentially the pattern. And I'm going to show you how we do this with SuperDuperDB. So if you've been watching any of my other videos, you'll know that I've been building out this AI agent bot network at the moment. So I thought what I could do is use SuperDuperDB to host my agent directory. And what I mean by my agent directory, a list of all the AI bots and what actions they can perform and what queries you can ask it. So if we look at Visual Studio Code for a second, you can see that I've created a JSON file in advance which has a list of the AI agents that are going to be part of my bot directory. And you can see I've got a whole set of bots such as TimeBot, and TimeBot is an AI agent that tells the current time in the UK, but I've got variations of that as well. TimeBot USA, TimeBot Asia, TimeBot Europe, TimeBot Australia, and then I've got some fun ones as well. So I've got Mischievous TimeBot, who will intentionally tell you the wrong time, and Binary TimeBot, who will report the current time in a binary format, as well as other bots that are not time related, such as an Echo bot, a math bot, and even a joke bot. So that is the data that I have, and it's in JSON format. So when I want to ask questions such as what's the current time in New York, or what's the current time in Tokyo, I don't want that to go off to the World Wide Web and go answer the question, right? What I'm wanting to do is go and ask one of these TimeBot agents what the real question is, right? So as you understand, that AI agent network is going to be super useful because lots of bots can come in there and answer those questions. But what I need to be able to do is allow the users to be able to discover which bots are on the network and what sort of questions they can ask. So you can see that JSON file has all the information that you need. So now if I want to then query which bots are available, I don't want it to be using its own model knowledge base. I want it to be using this JSON file as its knowledge source to answer my questions. I don't want it to be sort of making up some sort of time bot or AI agent that doesn't exist or is out on the internet. When I ask a question like, what AI agent is capable of telling me the time in the UK, I want it to come back with TimeBot UK can do that, and then I can go off and interact with TimeBot UK. So now that we understand the data and the problem that we're trying to solve, let me actually show you the final working application, and hopefully this will make sense. So I'm going to run this Python SuperDuper query. And as you see there's a whole lot of stuff going on. You don't need to worry about it just now. But essentially the question I've asked is, what is the ID of any agent that could tell me the time in Madrid? And you can see the answer is the ID of the agent that could tell me the time in Madrid would be TimeBot Europe. And if I come back into my JSON file, there you go. You can see TimeBot Europe. TimeBot Europe helps users find current time in various European cities. So it's using its own knowledge within the model to understand what the question was. It's using its knowledge of the world, i.e. Madrid is in Europe, to be able to do a better search. And then it's using the knowledge of the document base to be able to come back and say, these are the time bots that are available. And this one is going to be most likely to satisfy that response. And then it's going to come back with the final response, saying, hey, you want to use this one. So that's kind of how that process kind of works. So if I change that question from what is the ID of any agent that could tell the time in Madrid to are there any inaccurate agents that I shouldn't use? And then if I rerun that query, it should come back and tell me that I shouldn't use the inaccurate time bot that I have. There you go. The mischievous time bot is the inaccurate agent and for humor. Therefore, if you're looking for an accurate current time, it's advisable not to use that. So again, it's using its understanding of the query. It's going off to my document set to get the right answer, i.e. a mischievous time bot. And then it's giving me this result to say, hey, don't use that for this reason. So now that we understand what that works, we are now going to build this with SuperDuperDB. The first thing that I need to do is I need somewhere to store my data. Now, of course, I could use something like Sqlite that is supported by SuperDuperDB, but I'm going to use MongoDB in this case because I think it's quite cool to be able to host that on something like MongoDB. Again, I could use something like Postgresql, whatever. If you go to cloud.mongodb.com, you will be able to sign up for an account and get a free database that you can use and follow along. So once you have signed up, you can click on new project and you just need to give it a name. So I'm going to call it AI agent directory. And then all I'm going to do is click on create project. Once I've done that, I then just need to create a deployment for my database. So I'm going to click on create deployment. And here you go, there is M0 or M0, and it's free for learning and exploring MongoDB. Of course, there's paid versions, but I'm just going to use the free version. I'm going to use AWS, and because I'm in Europe, I'm just going to use Ireland here. So I will call this AI agent directory cluster, and then I am just going to click create, and then it's going to want a username and password. I am obviously going to blur this bit out so that you can't see that. I'm going to click on create user, and then I'm going to click on finish and close, and then that will go ahead and create my brand new database cluster. So to do that, I'm going to click on the connect button here, and you see there's a kind of drivers piece. So I'm just going to select that. And then if I pick something like Python, we're going to use Python today to connect to SuperDuperDB. You can see there, and it gives you some useful stuff. It's going to tell you we're going to use PyMongo. That's the same library as we're going to use. And then you can see here that it's giving you a nice little connection string that you to use in your code. So we can just copy that. And then of course you'll need to have saved your password from earlier. Once I have got that, I am going to go into my .n file. So we will create a .n file, and I need to have something called MongoDB URI. And then I'm going to paste in that very same connection string that we pulled from connect. And then the next thing I need to do is just put in the password that we generated earlier into here, and then we're good to go. You don't need to worry about OpenAI API key for just now. That is going to be for later on. So I put my password in here, and then we will be fine. Now, my actual username and password is in the .env file. I'm obviously not going to show you that. So there we have it. As it stands, we should have a .env file, a .env.example file. I've got a .ignore as well. And we've got this AI agents JSON file. Of course, I will put that all up on my GitHub later, and you will be able to use that. All right, next thing that I'm going to use here is I want to connect to my MongoDB up in the cloud. I'm going to use a tool called MongoDB Compass. So I'm just going to create a new connection, and then I'm going to paste in the connection string that we just constructed earlier. Again, my password, etc., is blurred out, and then I'm going to hit connect. And now I've got access to my database in the cloud. And again, you can just go to mongodb.com and download the Compass tool. It's completely free. And you can see at the moment, I've got no databases created just now. What we are going to do is we are going to create a database, and we're going to do that insert there. The first thing that I'm going to do is I'm going to insert the data manually with MongoDB, and then I'm going to show you how we can do it with SuperDuperDB. Alrighty, so the first thing we need to do is we're going to install pip install pymongo. Pymongo is the Python MongoDB client library that you use to connect to your MongoDB. So I'm going to install that. You see it's already installed on my machine, so that's okay. And because I'm using .env files, I'm going to install Python .m so I can deal with my .env environment. And again, you can see I've already got that installed in my machine. We've already connected up to Atlas, so we know that that works. We've got a good connection string that's okay, and it's in our .env file at the moment. So what we're now going to do is we will now insert that JSON document into our MongoDB. So I'm going to create a new file. I am going to call that insert_agents.py. So first thing I need to do is import the Mongo client from the pymongo library. So we'll just do from pymongo import Mongo client. And we also need to import .env as well. So we'll do from .env import load.m. And also, because I'm going to be dealing with the environment variables, I need to import OS, and I'm also going to be importing JSON as well. Now that I've done that, I need to load my environment variables. So to do that, I'm going to type in load.env, which essentially loads the environment variables. Once that's in place, I can access them through the os.getm. So we will just load the MongoDB connection string, and we'll do that with mongo_URI equals os.getm. And then we're just going to put in the name of our environment variable, which is MongoDB_URI. And again, if you're unsure what it is, just go check out your .env file and you will see what it is called. The next thing I need to do is connect to the Mongo database. So I will just type in client equals Mongo client. And we're going to pass in the Mongo URI. And then next thing I need to do is set a database that I'm going to work with. So the database we are going to create is going to be something called AI agent. So we'll say db equals client.ai_agents. Now, the next thing that we will then need to do after that is we need to create a collection of documents. So if you think about what is in our agent network, we are going to essentially want a document per AI agent. So we'll have one for time.usa, one for time.europe, etc. And each document needs to live in an overall collection. So that will be our AI agents collection. So therefore, we need to specify what that collection is. So we will say collection is equal to DB, which is our AI agents database, because collections need to live within a database. And we'll say DB agents. So the name of our collection is agents, and it's going to live in the AI agents database. So the interesting thing about MongoDB is that a database can't exist without a collection. So as soon as I create the agents collection, then that's automatically going to create my database as well. So the next thing we need to do is load up our JSON file. So we'll do that with open, and we'll pass in AI_agents.json, which is our JSON file. We're not writing to it, so we'll just set that as read, and then we'll say it's of file. And now I'm going to do a data equals json.load file. And that is now going to load my JSON file. So the last thing that we need to do is, now that we've loaded the JSON file, is we just need to insert the documents into MongoDB. So I can do that with collection.insert many, and I need to pass in data, and I need to give it the name of each essentially JSON element that I want to load. So if you look here, if we come back to our AI agents for a second, you can see within my JSON document, I've got agents, and then I've got each agent underneath there. So I'm essentially inserting many, and I'm passing in from my data the agents attribute. If I come back into my terminal and I just run Python insert _agents.py, it should insert that into MongoDB. So now that it's done that, if I open back up MongoDB Compass and then I do a refresh, you can see AI agents has now appeared, and we can see agents there, and I can see TimeBot, I can see TimeBot USA, and I've got the name, description, capabilities, example queries, etc. So far this is just standard MongoDB. I've taken my agent networks and I've loaded it into MongoDB. So where does SuperDuperDB come in? So if I was doing a traditional RAG pattern, as I said before, I would normally need a vector database, something like a ChromaDB or Milvus or Weaviate or something like that. And I know MongoDB has even got its own one in Atlas, but with SuperDuperDB, I don't need that extra infrastructure. I can use my database to hold my vectors, and I'll talk about what vectors are in a second. So we now need to take our database and see what happens when we use SuperDuperDB with it. So the first thing I need to do is install a package for SuperDuperDB. So I'm just going to type in pip install SuperDuperDB, best name ever. And then you can see it's already installed there, but we are now sort of good to go. So what I am now going to do is I'm going to take this insert agents that we've got, and we're going to do exactly what we did before, but rather than using our standard Mongo client, i.e. PyMongo, to do the inserts, we actually can use SuperDuperDB to perform the operations for us. Now, strictly, I don't need to do it in this case, but I really just want to kind of show you that you can do that. So we will now create a new file here. We're going to call it super_duper _insert _agents. And I'll just kind of show you how this works, and then that will allow us to get a little bit more familiar with SuperDuperDB. So the first thing that we are going to have to do is we're just going to need to import SuperDuper. So we'll just do from SuperDuperDB import SuperDuper. And then we've got a few more imports that we need to do because I'm going to want to work with collections. I'm going to want to work with documents. So I need to do some imports there. SuperDuperDB.backends.mongodb. So that will give us access to MongoDB. And then we're going to import collection. And then I'm also going to want access to the SuperDuperDB document structure. And I'll explain that in a second. So we will do SuperDuperDB.base.document, and we will import document. So that gives us the imports that we need. To be able to make this work with SuperDuperDB, there's a few changes that I need to make. So I still need to load my environment variable, so nothing changes there. I still need to load my MongoDB connection string, so nothing changes there. So this is where the first change is going to be. So at the moment, I connect to MongoDB through my Mongo client, and then I set the database as AI agents. What we're going to do with SuperDuperDB is just combine this all into one piece of text. So rather than having db equals client.ai agents, we're going to just go SuperDuper, and then we're going to pass in Mongo client as we did before. And we're going to pass in Mongo URI, and then I'm just going to pass in .ai agents as we did before. And then I can just get rid of my db.client agents, and I now have my DB as before. So all I'm really doing, and this is probably the key thing of SuperDuperDB, is you use your existing clients that you had before, such as PyMongo, and then I'm just making it SuperDuper. So all I'm doing is wrapping the SuperDuper command around that. And then I've got a SuperDuper DB. Now, once I've done that, I can do the same with my agents. So you see at the moment I've got collection is equal to db.agents, and I can just change that rather than doing this. I just put collection and then I put agents. So it's a little bit of a change because I want to use my SuperDuperDB collection rather than working directly with PyMongo's collection. Alrighty, so I don't need to do anything with my JSON file at the moment. I just load that as I would do before. But the next thing that I need to do is I need to take my JSON file and convert it into a format SuperDuperDB can understand. So there's a little bit of work to do there, but that's sort of fine there. So all I'm going to do here is say agent docs equals, and we'll just put in an empty array. And then I'm going to say for agent in data agents. So we're just going to loop through our agents collection here. And then we'll just put a JSON string here. And I'm going to do a JSON.dumps agent. The reason I am doing this is I want a JSON representation of my data. So as it stands at this point in time, my data is got individual key attributes, whereas when I do my search later on, I want to be able to access all of the attributes. So I'm just going to take my all of my content and I'm just going to convert it to a string, and then I'm going to save this in a new field in my document called search data. And then I'm going to call that JSON_string. And that is just going to save me from creating multiple indexes or just using one index as I go along. Again, you don't need to do that, but I found it's quite useful as a technique. So now all I'm going to do is append my document that I've created with my agent. So essentially all I've done is converted each agent from my JSON string, put it into this document format, and while I'm at it, I've just created this extra search data. Last thing that I need to do though is to be able to work with SuperDuperDB is at the moment you do a collection.insert many and then put the data agents there. So I need to sort of change this. So it's going to use agent_docs. And then I need to make a quick change here and say db.execute and wrap the collection insert. Apart from that, everything else is the same. So now if I come back into my MongoDB for a second, I'm going to delete this collection called agents. And now we're back to being fresh here. You see there's no database. And now if I run Python superduper insert agents, you will see it's come back with a load of stuff, but essentially it's done the job submitted, function, blah, 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 blah. So if I come back into my Compass DB and I click on refresh, you'll see it's now created AI agents. And there we go, timebot USA, and we're all good. Now there's a little bit of extra data here. You see search data, that's the one that we created. So we took the JSON string version of here. But beyond that, it's got this _full, but beyond that, it's pretty much the same there. There's this thing here called, there's a job, the function job. So in order to do that insert, it created a little job in there. So we've got something extra in there. It's not really critical, but essentially it's doing the same thing. So next thing that I want to be able to do is I've now inserted my data in there. Arguably, I didn't need to use SuperDuperDB to do that. I could have just done that manually as before. But again, I thought it was useful to do that. The thing that we are now going to do is we are going to take the insert agents, and now we are going to create something that's going to do the vectorization, right? So this is the key part. So if you think about a traditional RAG pattern, you need to take data out of your traditional database, i.e. in this case MongoDB, and then you need to convert that data into embeddings, right? And then load it into a vector database. With SuperDuperDB, you don't need to do that. That all works within your existing database, and that is the state the thing that we're going to implement just now. So we're going to call this superduper.listener. And essentially, we're going to take the same code that we had before, and we're just going to modify it a little bit to do the listening. So what's going to happen with the listening is it's essentially going to listen to the collection
and see if any new documents are being added or if the documents are changed. And when they change, then it's going to create the vectors one more time, and then update the MongoDB collection with the vector information. So we'll show you how that works. So to make that work, pretty much everything that we had before remains the same. We still need .env, OS, JSON. We still need a PyMongo there. We need SuperDuperDB. We need collection. We need document. But there's a few other things that we're going to need. So we need something that's going to do the listening and something that's going to access the vector index. So we'll call SuperDuperDB dot. So we're just going to add into SuperDuperDB where we'll import a listener, and we will also import vector index, and we're going to need that a little bit later. So in order for the RAG pattern to work, we need to be able to convert the content that we have into this embedding format. So it's a sort of native tokenized format. And now because we're going to be using OpenAI to do the queries, that's going to be the large language model that we're using. Of course, you can use others like Claude, Anthropic, Cohere, whatever, but we're going to use OpenAI in this case. So we need to be able to convert our documents into an embeddings format that essentially can be understood by OpenAI. So to do that, we are going to say from SuperDuperDB, and we're going to access external, so .ext OpenAI, and we're going to put model, and we're going to import OpenAI embedding. And we will use that a little bit later on. Don't worry about that too much just now, but we've just made the imports that we need. Everything else here remains the same. Now, obviously, we don't need to read our JSON file because we've already done that. We're not inserting any documents, so we can just get rid of this, and we can get rid of this, and we can start from the point of accessing our collection. So the first thing that we probably need to be able to do is connect to OpenAI. So we will just put OpenAI connection string. Again, we're going to use .env here. So I'm going to create something called OpenAI API key, and that's going to be equal to os.getEnv. And I think I called that OpenAI API key there as well. So similar to the MongoDB connection. If you need to access that, if you go to something like, if you go to platform.openai.com, you can request some API keys. So if you click on API keys here, once you've signed up for an account, you can create a key. So you just click create new secret key, and then it will do that, and then you can paste it into OpenAI API key and your .env. And again, obviously I'm not going to show you mine for very good reasons. All right, next thing I need to do for the embeddings is I need to set my model. So the model in this case is going to be equal to OpenAI embedding, and the model will be text dash embedding ADA 002, and that is the embedding model that OpenAI uses for any embeddings. So now that's in place, what I need to do is essentially create a new index on my MongoDB, which is going to be a vector index, and that is essentially going to take all the documents, embed them, and anytime a new document is added to the collection, it will vectorize that, create an embedding by calling OpenAI and getting an embedding version of that document, and then it's going to update that document to have that embedding. So to do that, I'm just going to type in db.add, and then we're going to put in vector index, and then here the identifier is going to be equal to whatever we call the index. So in this case, I'm just going to call it AI agents vectors. Again, you can pick any name in here. And now I need to just specify the indexing listener. And in this case, it's going to be equal to listener. And then I need to say what I'm going to be listening to. So in this case, I'm just going to do a collection.find. So I'm just going to say, hey, listen to the whole collection. So that collection that we've got there is the, if you remember, is the agents collection. So anytime there's a change there, that's what I'm interested in. I'm specifically looking at a field of data in the document. So in this case, I'm going to look at search_data. Remember, I sort of, before I created a brand new field, which just contains the entire JSON string. I could just put one attribute if I want. If I just wanted to look at description, I could type in description there. But it's essentially just going to be a field in your JSON document there, ID, name, description, capabilities. But of course, I've created a new one which has got the entire JSON string there. So once I've got that in place, I just need to say what the model is. So model is going to be equal to model. And the last thing I need to do is just put essentially a limit on the chunk size of the embedding. So I'm just going to limit it to essentially 1,000 tokens. So now that I've got my code to add my new vector index, I can essentially run that by typing in Python superduper listener.py, and that is going to go and connect to my MongoDB. It's going to vectorize all of the embeddings, and then it's going to store that within there. So if I open up MongoDB now, if we just do a little bit of a refresh, you see there's a whole bunch of new stuff created. So you can see there's things like objects, you see parent-child mapping, etc. So it's got a little bit more complicated than it was before. But if we look at this, you see ID A01, there's timebot, capabilities, version, all that before. But look here, there's a new thing here called outputs, search data, and there you go, text embedding ADA002. And then we can look at that, and underneath there is all the embeddings. So those embeddings were created by going off to OpenAI. You pass in the document, and then OpenAI will create the embeddings for you. So it calls OpenAI API, and then you take that embedding, so it's the embedded version of your document, and then that is stored within MongoDB. And therefore, when you do your queries later on, and you're looking for the before documents that match the query, then it's actually using these embeddings to do the search. That's how the magic there. Now, in a traditional world, so such as where you're using something like Llama Index, and you're using a vector database such as Weaviate, ChromaDB, Milvus, or something like that, those embeddings aren't in your database. They're in the Milvus DB or the ChromaDB, right? They're not sitting in your original data. And that's the magic of SuperDuperDB, right? What it's doing here is, rather than you needing that extra infrastructure, it's taking those embeddings and then building it into your existing database structure, and then using your existing database to perform the vector search. That is the magic underneath this. The last thing, just before, I didn't show you doing this. There's just one thing I want to show before we go and then query that. In order to make this work with SuperDuperDB, you will also need to do an install of OpenAI. So you do pip install OpenAI. You need to specifically set the version to 1.12 at the moment. I'm sure that will change, but if you don't set that to 1.1.2, you will find you'll get a bunch of errors there, usually on the something about timeouts. But if you set it to 1.1.2, then you're going to be fine. So now that we've got our listener, and of course, one of the nice things about our listener, you could stick that in a job in the background. It could be constantly listening to the MongoDB. So as new documents come in, then it just updates the document to have vectors in there. So it doesn't need to be part of your process. It could just be sitting as a background job. So now that that's working, we've got our MongoDB updating. The last thing that we can now do is we need to create our inference thing, right? So we need to be able to query essentially our document database. So to do that, we are going to create ourselves another file. So we're going to come back into VS Code for a second. And this time we'll copy the listener again. And this time we will rename this to query. And there's a few changes that we need to make. So the first thing is we can just get rid of listener and vector index. We don't need that anymore because we're just going to be doing a query. We're just going to be accessing our MongoDB. We still need Mongo client. We still need SuperDuper. We still need load.env. We don't need JSON anymore. We obviously don't need OpenAI embeddings, but we do need OpenAI chat completion. And we can just pull that from x.openai. And then that makes our imports pretty good. We obviously need to load environment variables as we did before. We still need our Mongo client. We still need access to our collection. We obviously don't need OpenAI embeddings, and we don't need to access DB anymore. But what we do need to do is access kind of OpenAI's chat completion stuff. So we'll just say chat is equal to OpenAI chat completion. And we'll set our model is equal to, we'll use GPT 3.5 Turbo. You could use the new GPT 4.5 Turbo. You could use GPT 4 if you want, but 3.5 Turbo is pretty good. And I need to give it a prompt. I'm going to set that to a prompt template, and we need to define what that prompt template is going to be. I'm going to say prompt template is equal to here's the question with the context. Again, if I wanted to get really specific and say things like only use information that is provided, you will be able to do that. But you know, I'm just going to say here's the question, and therefore later on we will put what the question is. I'm going to add this to our DB, so db.add chat. And now we're actually ready to ask the question that we want to ask. So we're going to set our question is going to be equal to what's the ID of any agent that could tell me the time in Madrid. And then I'm just going to set my num results is equal to 5. You know, I'm only interested in getting 5 answers back there. So finally, what we need to be able to do is take our question, i.e. what's the ID of the agent that can tell me the time in Madrid, and I need to send that to OpenAI to be able to go and understand what that query is. So it will take that query, it will understand it. It will turn the query into a vector format. It will then bring that back here. So that's what happens with this db.predict, and it's going to tell us you know, what those vectors are, and then we're going to take those vectors and then run them through a document search on our MongoDB. So by calling db.predict, essentially we need to tell it our model. So in this case, it's going to be GPT 3.5 Turbo. We need to tell it what the question is. It's going to go and send that off to OpenAI. It's going to come back with some vectors. And then when we get the vectors come back, it's going to call collection.like. Yep, so it's now calling our MongoDB. It's going to pass in that essentially the question, but of course it's going to be running in the kind of vectorized form. It's going to look up our vector AI agents. It's going to return 5 results where those vectors match the closest. It's going to do the find, and then it's going to come back with the search data. And the context key is telling it which data am I going to be able to use there. Once I've got all of that, I can then just do a print output dot content. And of course, if I want to print the question as well, I can go print question. And now I can do a Python SuperDuper query, run that. As you can see there, I've asked what's the ID of any agent that can tell me the time in Madrid. And the ID of the agent that can tell me the time in Madrid is AI004, TimeBot Europe. And of course, if I want to ask it different questions, you know, I could ask it what's the ID of any agent that could tell me the time in New York. We'll run that again, and you see it's going to come back. The ID of the agent that could tell you the time in New York is AI002. And then, of course, I can come back and say, are there any agents that I should not work with due to accuracy issues? Just clear this, run it one more time. And there you go. Based on the information, the mischievous timebot AI006 is an AI agent that intentionally tells their own time, adding a bit of humor and unpredictability. Therefore, it's not suitable to work with if you require accurate time reporting. I can even ask it questions like, what are good queries to interact with timebot UK? And there you go. It's looked at this and said, what is the current time in the UK? Tell me the current time in London. What is time in Manchester right now? Time in Edinburgh. So it's using the information there to give some pretty good examples from there. Anyway, as you can see, the retrieval augmented generation pattern is super powerful. As you've seen from this, you are essentially you're using the large language model to understand the query, And of course, it's going to take that query, it's going to return it back as a vector. And then, of course, instead of going off and looking at the model's own information, it's going to be able to use your documents, your information to be able to come back with those answers. So in this case with SuperDuperDB, we can actually vectorize all of our documents in something like MongoDB or Sqlite or wherever. And then rather than using a third-party vector database, you can actually store the vectors within MongoDB via SuperDuperDB, which is just a stunning technology. And then when I do my query, of course, and then finally, when I do my query, I pass my query to the large language model. It gives me the embeddings of the query. I pass that out to my vector database, which then able to interpret that, bring the documents back, and then use the large language model one more time to sort of bring that query and give back a final response using the information that it has in its own model, plus the information in your document to give the response. And therefore, you're no longer relying on the knowledge of the model, but you're relying on the knowledge of your model. So in my case, build my AI agent network, I can essentially use things like Sqlite, I can use whatever, and I can have large language models use this. Now, there is a few limitations with SuperDuperDB at the moment. There's some databases that are not supported at the moment. I guess that'll come in time. It only supports Python just now. I imagine that they're going to do Rust and JavaScript, TypeScript at whatever point. It's fully open source, so I guess you could do that yourself. It hasn't got integrations with things like LangChain just now. I imagine that will come in time, but I think it's a super amazing or a super duper framework, and I think it's really going to take off. So really great work from them. I really like the fact that I don't need an extra vector database in my architecture, and I can just use my existing MongoDB or Sqlite. So really nice framework, really love it, and I think it's going to be super powerful. Anyway, I know this has been a bit of a long video, but hopefully it's been useful, and I'll catch you on the next one.